Atoms. They are the building blocks of our universe, the fundamental particles that constitute everything we see, touch, taste, smell, and even those we can't perceive. They are in the air we breathe, the food we eat, the stars we gaze at in the night sky, and yes, they're even in us. In fact, our bodies are bustling metropolises of trillions upon trillions of atoms. But why atoms? Why not something else? Well, the answer to that lies in the very nature of atoms themselves. You see, atoms are incredibly stable. They're made up of even tinier particles, protons, neutrons, and electrons, all arranged in a way that makes them incredibly resilient. And it's this stability that allows atoms to combine and form the myriad of substances we see around us. Yet, atoms are not just about stability, they're also about diversity. Even though all atoms share a common structure, they can differ in the number of protons, neutrons, and electrons they contain. And it's these variations that give rise to the different elements in the periodic table, from hydrogen, the lightest, to oganesson, the heaviest. Each element has its own unique properties, leading to an almost infinite variety of materials and substances. But perhaps the most fascinating aspect about atoms is their sheer number. Did you know there are more atoms in a single glass of water than glasses of water in all the oceans combined? It's a mind-boggling fact that underscores the unimaginable scale of the atomic world. So, atoms are everywhere. They're stable, they're diverse, and they're incredibly numerous. They are the silent architects of our universe, shaping everything in it, from the tiniest grain of sand to the largest galaxy. But how did we come to know about these tiny particles? How did we uncover the atomic mystery? Now, let us embark on a journey through time to understand how humanity discovered and understood atoms. Our story begins in ancient Greece, with a philosopher named Democritus. Born in the 5th century BC, Democritus was an intellectual maverick, a free thinker who dared to question the nature of reality itself. He contemplated the nature of matter, the substance that makes up everything we see, touch, and feel. He wondered, if you break a piece of matter into smaller and smaller pieces, is there a point where it can no longer be divided? His answer to this question was a resounding yes. He proposed that matter is composed of tiny, indivisible particles. He called these particles atomos, the Greek word for indivisible. Democritus imagined a universe teeming with atomos, moving through the void. He believed that these atomos were eternal, unchanging, and that they came in an infinite variety of shapes and sizes. He theorized that the differences in their shapes and sizes were what gave matter its various properties. But the world was not ready for Democritus and his atomos. His ideas were largely dismissed by his contemporaries. Plato, for one, was a vocal critic. He believed in a different model of reality, one based on perfect forms rather than indivisible particles. The atomos theory was swept under the rug of history, forgotten for centuries. Yet, the seeds of thought that Democritus had sown would not remain dormant forever. His concept of atomos would resurface centuries later, becoming the cornerstone of modern atomic theory. Today, we know that atoms are indeed the building blocks of matter. We know that they can combine in countless ways to create the myriad forms of matter we see around us. Democritus may not have had the technology to prove his theory during his lifetime, but his intellectual bravery paved the way for future generations. His vision of a world made up of tiny, indivisible particles was revolutionary. His atomos, dismissed in his time, are now the foundation of our understanding of the physical world. Despite the brilliance of his theory, it would take centuries before it gained acceptance. But when it did, it changed our understanding of the universe forever. Fast forward to the 19th century, the era of scientific revolution. In this age of enlightenment, a new breed of thinkers emerged, daring to peek into the unseen world of atoms. Among them were John Dalton, J.J. Thomson, and Ernest Rutherford. These men, with their insatiable curiosity and unwavering determination, pushed the boundaries of our understanding one atom at a time. Let's start with John Dalton, a man of humble beginnings who became the father of atomic theory. Dalton, a meteorologist by profession, was fascinated by the behavior of gases. His tireless investigations led him to propose that matter, in its most basic form, is composed of tiny, indivisible particles called atoms. Dalton's atomic theory was a giant leap forward, providing a foundation for others to build upon. Next in line is J.J. Thomson. A physicist of extraordinary talent, Thomson embarked on a series of experiments using cathode rays. His findings were astonishing. He discovered a particle smaller than an atom, which he named the electron. This was a game changer. Thomson's discovery shattered the idea that atoms were indivisible and marked the beginning of subatomic physics. Finally, we have Ernest Rutherford, the man who gave us the planetary model of the atom. Rutherford, a student of Thomson, conducted an experiment known as the gold foil experiment. He fired alpha particles at a thin sheet of gold and found that some particles were deflected at large angles. This led him to propose that atoms have a small, dense, positively charged nucleus, revolutionizing our understanding of atomic structure. Each of these scientists, with their unique contributions, ushered in what we could call an atomic renaissance. They challenged established ideas, broke down barriers, and unveiled a world far more intricate and fascinating than anyone could have imagined. These scientists paved the way for a new understanding of the universe, one atom at a time. Enter the 20th century, the age of quantum mechanics. The quantum leap, as it's often called, was a seismic shift in our understanding of the atom. A revolution led by some of the greatest minds the world has ever known: Niels Bohr, Albert Einstein, and Werner Heisenberg. Niels Bohr, the Danish physicist, was the first to propose a model of the atom that incorporated quantum theory. He suggested that electrons orbit the nucleus at certain fixed distances, or energy levels. This meant that electrons could jump from one level to another, but they couldn't exist in between. This quantum leap, as Bohr termed it, was a groundbreaking concept that changed the way scientists viewed the physical world. Then came Albert Einstein, the theoretical physicist whose name is synonymous with genius. Einstein proposed the idea of light quanta, or photons, and explained the photoelectric effect. This is when light shining on certain materials can cause them to emit electrons. This was a revolutionary idea that further cemented the role of quantum mechanics in understanding the atom. Finally, Werner Heisenberg, the German physicist, proposed the uncertainty principle. This theory states that it's impossible to simultaneously know both the exact position and momentum of a particle, like an electron. This principle shattered the deterministic view of physics and introduced a new level of unpredictability into the field. These three trailblazing scientists changed the face of physics with their theories about the atom's structure, energy, and uncertainty. Their work not only explained the atom in a way that had never been done before, but also paved the way for a whole new field of study. They gave us quantum mechanics, a field that continues to challenge and inspire scientists to this day. It's a field that not only seeks to explain the inner workings of the atom, but also aims to unravel the mysteries of the universe itself. Their work not only explained the atom, but also opened the door to quantum mechanics, a field that continues to baffle us. So, why are atoms so important, you might ask? Well, to put it simply, atoms are the very essence of existence. They are the fundamental building blocks of everything we perceive in the universe. From the air we breathe to the stars that twinkle in the night sky, atoms are more than mere particles. They are the architects of matter. They come together, forming bonds to create molecules, which then band together to form compounds. Every object, every life form, every piece of matter you can see, touch, or taste is an intricate matrix of these atoms. They are the bricks and mortar of the universe, but atoms do more than just sit around being building blocks. They are active participants in the dance of life. They engage in a ceaseless ballet of chemical reactions, constantly breaking and forming bonds, creating the energy that powers our bodies, fuels our cars, and lights up our cities. Every breath you take, every beat of your heart, every thought that crosses your mind is a result of countless atoms interacting and reacting with each other. Moreover, atoms hold the key to understanding the universe. The study of atoms has led to some of the greatest scientific discoveries and technological advancements. From the humble light bulb to the powerful nuclear reactor, from the invention of the transistor to the development of quantum computers, atoms have been at the heart of it all. Atoms are the language of the universe. By studying them, we've been able to decipher the cosmic messages written in the stars, uncover the secrets of black holes, and even glimpse the birth of the universe itself. They've helped us understand where we came from, where we are going, and perhaps most importantly, what it means to be human. Indeed, we live in a universe of atoms, an atomic realm that continues to fascinate and inspire us to seek answers to the mysteries of existence.